Yeah, hello everyone. You are welcome to the fourth part of the phase 2 of the AI in Civil Engineering course. So now we'll check the multicollinearity. So first of all, what multicollinearity means is that you would agree that we have determined the correlation. We have also checked for the mutual information. But now multicollinearity is that we are trying to see if there is no feature that is dependent on another feature. I mean, what we have checked with mutual information is to see if there is a relationship, non-linear relationship. What we checked with correlation was to see if we had a mutual relationship. But in multicollinearity, what we're actually checking is not simply a relationship. It is a relationship, but not simply a relationship, but a dependence. If this feature is depending on another feature. All right. So in this case, we want to deal with the multicollinearity because you can think of, let's say, for example, you have one feature which is water, you have another feature which is cement, and then you have another feature which is water to cement ratio. You will agree with me that water to cement ratio, we have multicollinearity with water and multicollinearity with cement, because the ratio, water to cement ratio itself, is just the division of water divided by cement. So there is no how you calculate water to cement ratio without having to calculate water and cement. You understand? So that is the concept of multicollinearity. So in this sense, for us, it is not beneficial for you to introduce these features separately to your model. You should not introduce water, cement, and also water to cement ratio in your model at the same time, because these three data have multicollinearity. You understand? So you either introduce water and cement, or you just introduce water cement ratio. You understand that kind of concept. So that is what multicollinearity is all about. So we need to check that in our model. So we want to check if we have that in any of this model, whether age, water, cement, superplasticizer, and all of this, if they have multicollinearity. If they do have, we will have to deal with them. You understand? So how do we do that? Well, we will be using variance inflation factor as a factor to establish if this has a multicollinearity. And how do we do that? If we have, let's say, a factor of between 0 and 10, we can still say that is fine, although 0 and 5 is better. If you have something between 5 and 10, it's some moderate multicollinearity. But when you have above 10, then it is essentially, it has high multicollinearity, and you need to deal with that. Okay? So in order not to waste more time, I would say we code it directly, but just a little bit of fundamental. I will take a snip. Okay. So multicollinear, what's it called? Variance inflation factor, which I call VIF. VIF is 1 over 1 minus R squared. Okay, so this is just a formula, and this old denominator, we call it tolerance. So how do we actually calculate VIF in essence? So let's say, for example, we have this data. We have age, we have cement, we have water, and then we have, let's say, fly ash. So let's say these are all of our data. Okay, you have something like this: 4, 5, 6, 1, 2, 3, 4, 5, 6. So this is our data. So what multicollinearity will do is that it will, first of all, what VIF method does is that it will I mean, you will agree with me that all of these 4 columns that I have written out, they are features because our target is strength. When you are trying to calculate VIF, you are bothered about the feature. You are not bothered about the target. Because what you are trying to see is if there is any relationship between the features, not relationship between the feature and the target. If there is a relationship among the features, okay? So in order to calculate the VIF, what VIF does is that it takes the first row like this, it takes this one, it treats it as if it is the Y, it is the output. And then all of this, the rest, they will be the input, okay? The X. So that will be what it will do in the first iteration. So it will simply calculate a linear regression on this. So it will take this as the Y and this as the X. So it will, of course, use the formula Y equals to mx plus c, okay? So Y will be equals to mx1 plus mx2. The x1 will be cement, the x2 will be water, and then the, let me say m2, m1, yeah, then m3, x3 plus c. So the m1 is the slope one, which is the weight, we call it weight actually, and then x1 is cement in this case, x2 will be water in this case, then x3 will be fly ash, then c will be the intercept, will be the one to create the intercept for ourselves actually. That will be the first iteration. And then when it does this, it will calculate r square from that value. It will calculate r square, then to do 1 minus r square, then 1 over this. Then it will calculate VIF for age. Then it will go again. It will take cement. It will take cement. Now, in the second iteration, it will take cement as the output, and then age, water, and fly ash, they will become the input. So in that case, x1 will be age, x2 will be water, x3 will be fly ash, and y will be cement. Okay? Then it will do the third iteration. The third iteration, water will be the output. It will do a linear regression again. So in that linear regression, age will be x1, this will be x2, this will be x3. From the result, it will calculate r square, it will calculate VIF on top of this. So it will go on, and on. All right. So basically, if you have the time, you can simply just write the code, take an output, calculate a linear regression, determine your r square, use this formula, and then you compute all of this. But it's going to take, a lot of time. Not a lot of time, actually, but there is a library that does all of this for us. So we're simply just going to use the library. All you just need to do is to understand the intuition, which is what I've explained. Quite short, actually. So the library, I have installed the library. I've imported the library. This is the library, which is from Start Model, from Outlier Influence, import variance inflation factor. Okay, so we'll be using this variance inflation factor, which stands for VIF. Okay. All right, so I come down here. Now, the first thing I do is I will create a copy of the feature the feature data frame. So I will simply say x.copy because I want to create a different cell. Now, if I view this xVIF dot head, it's simply going to be the same cell as, it's going to be the same data frame as the input data frame, okay, originally like this. So what I'm going to do right now is to add I want to add a different column that will just be named intercept, and in all of this the value will just be 1 1 1 1 1. So the VIF is going to take that constant value as the intercept in order to calculate to use the linear regression model and calculate the r square and do the 1 over r square. Okay, so I will call that intercept, and then the value will simply just be 1. Okay, then I run this. So now you have that new column, and then all of this is intercept. Okay, so the next thing that I will do now is that I can simply just create a data frame that has 2 features. So in that feature, the feature 1 will be, that has 2 columns actually. So the first column will just be all of the features that I'm interested in, and then the second column will be the VIF. I will call this, let me say, VIF data frame. VIF data frame equals to PD, which is panda dot data frame. Be careful, that is capital letter. All right. Now I have the empty data frame. This is an empty data frame. If I run this, it's just going to be an empty data frame, I only created it, nothing is in there. So I will append 2 columns in there. The first one will be feature, and the second one will simply be the VIF. So I will, the same way, when you want to create a new feature, VIF data frame, I will call this features. And what will be my feature? My feature will simply be the name of all of the, actually, I want to see this. So I'll say copy. Let me put this in a different cell. Yeah, something like this. Okay, so what will be my features? My feature will just simply be just the name of this, all of this name. I will arrange it in column wise. So what does that mean? It simply means I need to do xVIF, which is this one, xVIF dot columns. Okay. So now if you check the VIF data frame, this is what I have. So now I have this, initially the data frame was empty. What I just did was to create a single column. So that column is features. So I have cement, blah, 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 all of them. I will create another. I'll create another column just at the side of features, and that will be called VIF. VIF. In this case, I have not calculated the VIF, so I will initialize it to be 0. Okay, 0 throughout, 0. So in this case, I'm saying the VIF is 0, but obviously I have not calculated it. So when I calculate it, I'm going to replace these values. Okay, so next I will create another cell because I just want to see this. Okay. Now the next thing I need to do is to simply just calculate the VIF. Quite straightforward, right? To do that, I can say let's say create a list. I would say VIF holder equals to an empty list. So currently I don't have a list. Okay, so I will, as you know, the VIF is something iteratable. So you do for the first what's it called, the first column you do for cement, where you take the cement as the output, and then the rest will be an input. You calculate the VIF. You do for the second one, you do the VIF. You do for the third one, you do the VIF, just as I explained in this. So what we need to do is to use a for loop. All right, so we can simply just do a for loop. So I say for I in range what's this called, xVIF, in range xVIF dot shape. Then I'll pick the first one. You can simply, you can simply say for I in range 8 or in range 9, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So instead of simply just writing for I in range 9, because if you do, let's say, if you do Control C, Ctrl V, and you do, no, don't do shape. If you just do shape like this, Ctrl C, that was not a cell. If I run this, you will see I will have 919, which is the number of observations, and this is the number of columns. So this is index 0 and this is index 9. So if I simply now say give me 0, what I'm trying to pick, sorry, give me 1. Oh really, I needed 1 here. So if I say give me 1, I'm trying to pick 9. I'm trying to pick 9. So instead of just writing, I mean, for the understandability of the code, that's why I wrote this. So you could simply just write 9 in there. Okay, so I have a column. What I need to do is to calculate the VIF. So I will say the VIF will be variance inflation factor. And what do I pass in the variance inflation factor? I need to pass the actual value of what I have in here. Okay, it will be the actual value of what I have in this data frame, which is xVIF. So it will be xVIF dot values, and then because it is iteration, so it will first of all pick the first one, which will be cement, I guess, cement. So you pick the second one. So this will calculate the VIF, and then I will append it into this. So I will simply say VIF order dot append VIF. So what this means is that if this line helps us to calculate, don't forget that this variance inflation factor is simply just calculating the VIF. So what I did was to bring all of the values of the data frame, and then I'm saying this is the output in this case. So the output is going to be the first iteration, then go second iteration, third iteration. Okay, then this line will return a VIF factor, because this will calculate that linear regression, calculate the R square, do 1 over R square, and return the VIF factor. So this line will return the VIF factor, and this line just helps us to append it into this empty list. Okay, so now if I check the empty list, if I say VIF order, if I check that empty list, I will see this. Okay, so I will see all of this. All right, good. So I'm going to Ctrl X this and paste it in this position, so that I have it in the same place. I like to do my work after the order. So now that I have my VIF order in here, what I need to simply do is to replace this 0000 with what I have calculated, right? So I can simply say that what's this data frame called? It is called VIF data frame, right? So the same way I had it here, I can simply say VIF Ctrl C, Ctrl V. So instead of equating it to 0, I would just say equals to VIF order. If I run this, okay, now I need to run VIF data frame. So if I run this, now I have so now if you look at the value, you will see that cement has a VIF of 7.4, blast furnace slag has a VIF of 7.7, fly ash has 6.4, water has 6.1. Obviously the lower the better. Okay, so as I said, if we have something between 0 and 5, it is considered good, and if you have something between 5 and 10, it is considered moderate multicollinearity. But then if you have something over 10, if you have VIF over 10, then that is regarded as high collinearity. Okay, so obviously intercept is just there for us to be able to calculate this. So this is not part of our original features, so we are going to drop it anyway, so it's not a big deal. So among all of these, none of them among all of the ones that we require, none of them is over 10. So I don't think we need to drop anything. Okay, we don't need to drop anything unless you just want to maybe, in some certain cases. Okay, so the ones that actually make sense is super plasticizer, because this is less than 5. It is very small, and age. It doesn't have any dependence on any other feature. Okay. So this is what multicollinearity is. Then with this, we have come to the end of the data exploration. Then in the next aspect, which is phase 3, we will dive into feature engineering, and then we will see what that has for us. So see you there.